Hi all, I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. In this video, let us see about another type of waveform generator which is known as Astable multivibrator. Before going into Astable multivibrator, we need to know what is multivibrator. A multivibrator is a circuit that generates different types of output waveforms like square wave, rectangular wave, and pulse waveforms. So it is also known as non-linear oscillator or function generator. There are three types of multivibrators which are astable multivibrator, monostable multivibrator, and bistable multivibrator. As the name suggests, astable multivibrator does not have any stable state. It consists of only two unstable states. It does not require any external trigger pulse. In monostable multivibrator, you have one stable state and one unstable state. Here, the output switches between the stable and unstable state with the help of an external trigger pulse. Next one is bistable multivibrator. So in bistable multivibrator, you will be having two stable states. So the output will switch between the two stable states with the help of two trigger pulses. So when first trigger pulse comes, it will switch to the first state, and when second trigger pulse comes, it will switch to the other state. Next one is we'll go into detail about astable multivibrator and its working. So it consists of two quasi-stable states. So the output will switch between these two states automatically. No external trigger pulse or signal is needed here. So it is known as free running multivibrator. So this is a circuit diagram of a astable multivibrator. So here if you see R1 and R2 is connected as a potential divider to VP, where VP refers to the reference voltage. So the input is Vn. So Vn is connected as a positive feedback from the output. It consists of two components, resistor RF and capacitor C. So the reference voltage can be set as two types, upper threshold voltage and lower threshold voltage. So the reference voltage is nothing but the voltage at this point from VP to ground. That is the voltage across the resistor R1. So there are two conditions here, upper threshold and lower threshold. So assume that your output is at plus Vsat. So when the output is at plus Vsat, the voltage that is obtained is upper threshold voltage, and when the output is at minus Vsat, the voltage obtained is lower threshold voltage. So first we'll see what is upper threshold voltage. So it is nothing but the voltage at the output into corresponding resistance divided by sum of the resistance. So we have considered that it is plus Vsat. So plus Vsat into R1 divided by R1 plus R2 gives the upper threshold voltage. Next one is lower threshold voltage. For that your output is at minus Vsat. So the lower threshold voltage is minus Vsat into corresponding resistance R1 divided by sum of the resistances R1 plus R2. Next, we'll go to the working of astable multivibrator. So as you know that automatically it switches between the two output states, plus Vsat and minus Vsat. So consider initially your output is at plus Vsat. So what will happen is because of this feedback, positive feedback here, your capacitor will start charging towards plus Vsat. Once the capacitor voltage crosses the upper threshold voltage, it will switch the output state from plus Vsat to minus Vsat. So at present, the output state will be at minus Vsat. So when your output switches to minus Vsat, your capacitor will start discharging. So this discharging takes place until your capacitor voltage reaches your lower threshold voltage. Once the capacitor voltage crosses the lower threshold voltage, the output will again switch back to plus Vsat. So this is how the working of an astable multivibrator is happening. So we will see the working in a help of a waveform shown here. So here Initially, output is at plus Vsat. Your voltage capacitor voltage starts charging. So until VUT is reached, after that, once VUT is reached, your output is switching to minus Vsat from plus Vsat. So once the output is switched, your capacitor starts discharging. So it discharges up to lower threshold voltage. So once the lower threshold voltage is reached, the output again switches back from minus Vsat to plus Vsat. So this continues. So again the capacitor will start charging. So charging and discharging of the capacitor continues as the output changes from plus Vsat to minus Vsat and minus Vsat to plus Vsat. So this automatically happens, and this timing period can be changed by changing the values of this capacitance and the resistance. So one important thing here is the duty cycle, which is nothing but the time at which the output is in high state. So normally for an astable multivibrator, the duty cycle will be 50%. So you can improve the duty cycle by adding diodes here at the output. So the charging and discharging can happen with the help of diodes, so that the duty cycle can be improved. Some of the applications of astable multivibrator are square wave frequency generator, timing oscillators, and flashing lights. So you can use astable multivibrators wherever automatically the output has to change between the two states. Hope you understood astable multivibrator in detail. Let us take up some assessment questions. So what is a square wave generator? The options are flip-flop, bistable multivibrator, astable multivibrator, and monostable multivibrator. So you know that the astable multivibrator is known as a square wave generator. Next one is, what is the duty cycle of the output of the astable multivibrator? So you know that the approximate duty cycle of an astable multivibrator is 50%. Next one is, how can the duty cycle be changed for an astable multivibrator? So the duty cycle can be changed by adding diodes to the circuit. Thank you for watching this video.